I'm doing a quick video just to show an easy way to use a different software than KiCad to make a little breakout board. So I'm just going to try to really quickly go through the process of making a quick one using EasyEDA and LCSC. EasyEDA is the free software provided by, well, you can pay for a more advanced version, but the free version is fine for stuff like this. It's made by JLC PCB, which is a sister company of LCSC. LCSC is basically the Chinese DigiKey, and they have, most of the stuff you get is components that you can find on LCSC. So today I'm just going to do an example. So I'm just going to do an FPC connector breakout board as an example. So the software is here, and I have a few projects that I've created on it. It's totally free. One of the things I like about it is it saves your projects on the cloud. So if you have this software, pulled up at home on a lab computer or anywhere, you can basically, it keeps it migrated fairly well. It's a little easier, I think, than using some of the other storage stuff. Some people are concerned about privacy with it, but I don't ever do anything that's, national security interest related. So you can download EasyEDA. Be sure to get the free version. I'm just going to create a new project, and I'll call it FPC Breakout. And so this FPC Breakout, it starts by giving you kind of a blank sheet. And for what we're doing here, I'm not going to go through the whole process of naming it. Once we have a blank project, I always like to, one of the things I like about it is they're pretty good about having a library of all the components that you can find with LCSC. So if you find your part on LCSC, which is probably something you can buy on DigiKey or Mauser or somewhere else anyway, if you find it and it shows it has an EasyEDA part, it's there, and it's pretty much guaranteed to be the right footprint, because the big thing they do with EasyEDA is they do automated assembly. And so when they have errors in a footprint, it messes up their assembly, and then that costs them money. And so there's a lot of feedback to make sure that the footprints are correct that you get from using this process. So I'm going to open up this just browsing this LCSC. If you just go to the product page or to the main page, they show you, I kind of have the window sort of zoomed in, but they have all these different categories. One of the hardest things I find is these are all translated from Chinese, and sometimes they don't translate right. Like a lot of times if you have like a blade connector, like a type of like spring-loaded metal pin that would grab onto a blade, like the types of connectors you have for batteries a lot, they'll call those like shrapnel connectors and things. And so, after a while you realize, oh yeah, sometimes they use the word shrapnel, which, I don't know, in English, shrapnel is usually just like a shard of something. It's dangerous. But they, whatever. You get used to the names after a while, but it can be hard to search sometimes if you don't know the right term. So in this case, I'm going to just go down to connectors. They have a whole bunch of different types of connectors here, and I just know that see, let's say blade/shrapnel. That's funny. So I'm looking for FPC, which is the flat flexible connectors. And they give you, just like with DigiKey, they give you an ability to kind of adjust what you're looking for. So I'm going to find a 0.5 millimeter pitch connector, and I want to get one that is, the package is, be careful selecting package, because a lot of times they have 4 or 5 names for the same thing, so you want to be a little careful. So I'm just going to start with just saying 0.5 millimeter, click apply. I'm also, for my purposes, just going to sort by in stock, so I'm going to click apply. Number of contacts, I'll find a 15-pin one. And so now this is going to give us all of the 15-pin 0.5 millimeter pitch FPC connectors they have. I'm going to look for kind of a weird one. So FPC connectors, usually it's a piece of polyamide substrate that has copper gold wires on one side of it, and they're exposed at the end. And so you have these little teeth in here in the connector that bites onto the blade. Most of these, the teeth are on the bottom. So like here you can see those little gold teeth on the bottom. Those are, so in that case, if you're using that connector, you'd have to have the little shiny gold side pins face down. I'm going to find one that connects. I'm going to try to find one that connects on both sides. So it allows you to have the FPC connector, the little ribbon, it can either be pin side up or pin side down. The danger of using that type of connector, the benefit is it gives you some flexibility in that you can connect your ribbon either way, in either direction. The downside is you have to know which way it needs to go in, because if it's backwards, it'll just be connected backwards. So probably not something you'd want if the user was plugging in the cable. But if you're using the FPC connector just for you to be the one that assembles it, it's probably fine to go with a reversible connector. So I'm going to see, the window's kind of tiny here, so they have bottom contact here, bottom contact. The other thing I like to do sometimes actually is I'll sort by in stock here, so, which I can't do right now. Okay, interesting. Why can't I sort by in stock? Huh. Well, whatever. I will. That's strange. Sometimes you have to select a certain number of options before it'll let you flip it down. Well, let's just do dual-sided contacts and hope we don't over filter this thing. Yeah, so this is grabbing on both sides. This one maybe looks pretty good. Can I sort by, oh yeah, sort by availability. It looks like it might already be sorted by availability. I'll sort by availability. It's usually not this bad to manage, but because my window is so tiny, it's given me problems. So this one looks pretty good. So I'm going to click on it and make sure it's what I want. Just going to take a look at the pictures to kind of get an idea of what it's doing. Yeah, so it slides in. It's got teeth on both sides. You flip the little bar down and it clamps those teeth together. Sometimes it's good to pull open the data sheet and take a peek. Yeah, so you can see here, each one of the, it's this U shape here that's got teeth on both sides, and so it pinches down and grabs both sides of the cable. So this thing looks okay to me. One thing I didn't check though is, do they have a footprint for this on EasyEDA? Which is going to be a problem if it doesn't. Sometimes it doesn't. Oh, it does. EasyEDA models, EasyEDA. We're not going to mess with that though. A lot of people, download those or grab these or something like this. We're just going to copy the part number, and we're going to go back to our page here, and I'm going to do place symbol, and I'll just do LCSC electronics and then paste that part number. And we find it, and there's a little button that says place, which means we can place it. I'll press, I think it's R in this to rotate. I'll press R, rotate it like that. And normally with these connectors, so they have pins 1 through 15 here. 16, 17 are usually mounting pins, which are important. It usually doesn't matter what you connect those to. Some people just connect them to ground. If nothing else, connecting them to ground, if there is for some reason some shield, it'll connect it. But the bigger thing, the reason you'd connect to ground is just usually part of a bigger plane of copper, so it's less likely to peel off if somebody gets a little rough with this. But normally the housing connectors are used for electrical shielding, in which case you want to connect it to ground. In this case, it really doesn't matter. We can probably leave it unconnected and it's fine. So when you're doing a breakout board, your goal is not to actually connect the pins to most signals. Your goal is just to connect them to something that you can touch easily with a jumper wire or something like that. So I'm going to do a header. I'm going to add a header to this. So to do that, I'm going to go back and go to connectors, and I'm going to find just header pins, and I'm going to do a standard for a standard one. And again, don't start clicking on too many of these things, because sometimes if the part doesn't have that category included, it messes you up a little bit. So don't start clicking color and all sorts of crazy stuff. You really want to click the minimum number of things you need to click. So I will see number of pins. So we'll do a 15-pin connector. And the pitch, we'll do 2.54 millimeters, and so 2.54 millimeters would be the standard 0.1 inch spacing. Click apply. And again, I'm gonna sort by availability just to see what's popular. If you sort by availability, it also usually has stuff that's more likely to have a thing. Now, we're not actually going to buy this header. We have tons of breakaway headers. I'm mostly just trying to get a part that's going to have the right number of holes that I need here. So it doesn't really matter which one I pick. I just know the footprint's going to be okay. It is an EasyEDA model. So again, I'm going to copy the LCSC part number, do place symbol, paste it, and just place that part. So in this case, you see the pin 1 and 15 are all in the same direction. It doesn't ultimately matter which way this thing goes, but pin 1 sometimes is a different shape. So I'm just gonna do something a little ugly, and I'm gonna rotate it like that. And then I'm gonna just connect these together. So basically I'm just connecting each pin of the FPC to the pins here. Oops. To the pins here. And with me, if I know they're ordered like this, I just grab, copy, paste. Oops. Hit the W key to draw the wire. Okay, now this is all we actually need for a breakout board for this. Is we just have our weird part, and then we have a header that we know we're going to be able to solder male pins into. And these aren't connected to anything, and that's fine. So what I'll do is I'll save this, and then I will go convert schematic to PCB. Normally you want to check the nets for errors, but there's, if there's an error, we'll be able to tell. They ask you for sort of default stuff. We're going to keep the copper at 2-layer. Board outline will change later, but rectangular is fine for now. Most of this stuff doesn't matter. Units, millimeter, okay. And it looks like it didn't give us our header, which is weird. So why did it not give us our header? Oh, that's weird. Let's try saving this again. Do design, update PCB. Oh, it said there's no PCB under this project because, well, that's weird. I tried to do an example and I mess it up first thing. Okay, well, I'm going to save that and then try to figure out why this isn't connecting. Convert to PCB, add the bomb. No, weird. Weird. Well, let's try it again. Okay, so that was weird. And then it pops up these settings for the minimum track width. Generally, that's fine for this thing for the minimum track width, but the actual minimum track width of the fab is 1.5 or 0.152. So if we want to, we can change this to 0.152. We don't want to use the minimum for just a breakout board, but it's fine either way. Okay, so now we have this both of these parts here, if we're doing a breakout board, it doesn't really matter what size we make these. It's not great that the header is like this. We might have wanted instead to break this into like 2 headers and do it 2-dimensional, but this is going to be fine. So I will just kind of center this thing. For a breakout board, it doesn't really matter. And then I'll wire this thing up, hit the W key, and that looks like a fine width for these wires. In this case, the wires are going to be a little tight once they get to these pads. So, but I will. Well, okay, that's great. So sometimes you'll notice that you, while you're doing this, that you don't have enough space to do everything that you wanted to do. I'm not gonna make this perfect. I wouldn't make it perfect even if I tried, but if you're watching this video, you can fast forward through this part. It's gonna be boring. I right-clicked and dragged to move the screen around. So now we came into a situation where we ran out of space, and so I'm going to hit escape on the wire dragging, and I'm just going to, because I screwed it up, I'm just going to make myself a little more room here. You see, if you start to if you violate an error check, it's going to do that little X there. That's how it rolls. So I'll just make myself a little more space. The downside of using this software is it doesn't doing basic stuff. If you're not trying to get too fancy, doing basic stuff is fine with this. It starts to become a problem if you if you need to do like really wonky stuff or have a really fancy board outline, then it starts to become a bit of an issue. But for our purposes, for just doing a breakout board, who cares? Okay, so that's not great, but it's good enough. So now we have our FPC connector and we have a header. The only other thing I like to add to this is I want to be sure to add labels so that when I get this back, I don't know, I could guess which one's pin 1. I could kind of look at the traces, but we might as well just add an indicator that, so I'll move the header labels and stuff really don't matter, but I'm just going to add labels to these pins just so it's clear what's what. So this is pin 1. Pin 1 starts over here. So I'm going to switch to the top silk layer and I'm going to place a text. And you see the text starts out as way too big. It's not a big deal, but so this text we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's where we're starting out. It's obviously too big. We're probably gonna have to fiddle with this for the spacing because once you switch to 2 digits, it messes with your spacing anyway. I'm gonna 1.6, 1.56 height maybe. Line width will go 0.15. Still not quite working. Height 1.2. 1.3. See, and this is where some other software tools would probably have like an automatic adjust option or something like that. So that looks pretty good. Yeah, not great, not great. So probably what I'll do is I'm going to add some spaces here. That, and then go back to it and change the height to 1.35. This is probably a mistake. I'm starting to feel like this is a mistake. Yeah, it's fine. That's fine. Okay, that's enough that, well, there we go. Beautiful, sort of. The better way to do it would be to have each one be a separate text, but for debugging, this is, I know which one's which. It'll be fine. Okay, actually, I might even just get rid of this label. So the label for the header here, I don't really need it. So I'm gonna click the header and display prefix no. Same with this thing. Display prefix no. And I might want to add some extra text to this to like say my name or something like, let's just do it. Place text. And of course it uses the same thing we had before. Put my name on here. And that's like that. And copy, paste. And I'm going to put the LCSC part number on here. So if I go back to, can go back. So this LCSC part number was that. Okay, so now I know who I am. I know who I am, okay? And I know this is a 0.5 millimeter FPC, and I got the part number there, so if I need to reference it again. Now the only other thing I have to do is make the outline what I need it to be. So you can totally delete this if you want. If you click on the grid out here, you can change the snap size. So this is pretty coarse, so I'm just going to do like snap size. The pin header is imperial unit, so I'm just going to do like 2.54 millimeters. And I might take this whole thing and just grid align it a little bit. Yeah, that'll be fine. Okay, so now I'm just going to go to board outline and do place. I think you have to do place track if you're doing a board outline. And actually, I'm going to do it like this. And you might say, well, hold on, John, that didn't fit the whole thing. It did not, but now I'm going to move it. So my snap is really coarse, but if I hold down Alt, it'll do the Alt snap and get me more in the center here. Okay, now this board edge is very close to this hole. It's gonna cut the end of the silk screen off there. That's fine. I just don't want this thing to be excessively wide, so it should be okay cutting that close to the hole. That shouldn't be a problem. So now I think I'm done. So I'm going to save it. It looks good to me. This is what I want. One thing I really like about EasyEDA is you can just do export, or generate Gerbers, and then I'm recording a video really quick. Oh yeah, sorry. We can check CRC, but I'm just going to click no. So that looks all good, and then I will generate Gerber, and whatever, that's fine. Okay, and so now it downloaded it. And that zipped up file is really all I need. So I might do another video where I show you how to check it. But basically that zipped up file has all the Gerbers that I would need, all the Gerbers that a fab would need to make this thing. So we're pretty much done. Thank you.